All right, guys, so usually on Fridays we're synchronous, right? But today we have to be asynchronous. You're going to be working on this assignment. What I'm going to do is I am going to go over, or I'll do one of each section. So you have 3 graphs. I'll do one graph. And then you have one where you have the equation given. So I'll do one of the equations, and then you'll do the other. And I think you can do fine on the matching, okay? So I'm going to do one. So let's go ahead and begin with number 1. These are characteristics of quadratics. And you're given the graph. And with the graph, you have to fill in all this information. So let me tell you what I would do if I was a student and what information I would fill in first. Okay. From the notes from yesterday, you should remember that domain, that's an easy one, because the domain is always all real numbers for quadratics. So you can just put right here, all real numbers. Or you can put the fancy R. Okay, so that's easy. You don't even have to do anything. It's always going to be that, okay? Another easy one that I would solve is the vertex. The vertex, remember, is the little point that's either the lowest or the highest part of the quadratic. So let me use a different color. So right here is your vertex. And this is going to be 2, 1, 2, 3, 4, 5, 6, 7, 8, 2, negative 9. I'm going to go here and put 2, negative 9. Now, which way is this parabola opening? Well, it's opening upward, right? So I'm going to go here and I'm going to put it opens upward. All right. And because it opens upward, here's the vertex. What do we call that vertex? Well, it's actually the minimum. Okay, pretend like you're walking right here. You're going to fall in the ditch, right? You're going to be at the lowest part of the graph down here. So that's why it's called a minimum. And what is that minimum? Like, how low do you go? And it's always going to be this, y equals, and whatever the y value is of your vertex, that's the number you use here. So there it is. Then you want to fill in the other information, like what are the x-intercepts? Well, I see one here and I see one here, because remember, x-intercepts are wherever it's crossing the x-axis. So negative 1, 0, and 5, 0. Okay, what is the y-intercept? Here's the y-axis. Your y-intercept is right here at negative 1, negative 2, negative 3, negative 4, negative 5. So my y-intercept is 0, negative 5. Notice the difference between an x-intercept. X-intercepts have a 0 on the y. Y-intercepts have a 0 on the x. Okay, so don't get confused. What is the range? The range is the y values. Okay, so right away I'm going to put a y. But it's not as easy as the domain. The range depends on how it's opening. If something opens upward, then look at your y's. Then those arrows are telling you that those y's get bigger and bigger and bigger. So you use the greater than and equal to. If they were pointing downward, like maybe on this graph, then you would put y less than or equal to, because those arrows are pointing down to the y on the negatives. Now, what number am I going to use? You're always going to use the lowest point, which is also the y value of your vertex. That's why the vertex is so important, because you kind of like use it in other places. Okay, so I'm going to actually, I'll highlight it or underline it so that you know that if you know this one, you're going to use those numbers here and here. Okay, and finally, the axis of symmetry, that vertical line that cuts it in half, has to be a vux that goes straight through the vertex. And what is its equation? Well, it's a vux. So vuxes are always x equals. X equals what? What did I go through? I went through the 2. X equals, so the x value of your vertex. So let me make a little note for you that this guy right here is super important because you'll use it on your axis of symmetry. And that's how you fill in all the required information for the graphs. Okay? Now let's move on to, well, oh, you know what? I'm going to show you something cool. Before I move on, I'm going to show you something cool. Notice how you don't have the equation of this quadratic, right? But if you wanted to get it, all you need is 3 points, okay? So let me make a little note. To find the equation, you need the vertex and 2 other points. Now, you want to get, since you're going to use the vertex, you want to get 1 point on the left and 1 point on the right of it, okay? So like, for example, for this one, I'm going to use the vertex, which is 2, -9. And I'm going to pick an ordered pair that is on the left of it, so the 0, -5. And I'm going to pick any other point over here. I can pick this one, or I can even make my own, like as long as it's perfect right here. So I can pick 1, 2, 3, 4, 1, 2, 3, 4, 4, -5. So you pick 3 points, the vertex being one of them, and you do this. Let me show you. You're going to go to your calculator. You're going to go to Stat. Okay? You're going to enter on Edit, and you are going to type in your ordered pairs. 0 is the x value of the first one. 2 is the x value of the second pair, ordered pair, and then 4. Then I go over here. -5 was the partner of 0. -9 was the partner of 2. And -5 was the partner of 4. Once you plug in your ordered pairs, you go to Stat again. But now go ahead and move it to Calculate. And guess what? This is a quadratic. So I'm not going to go pick number 4 because 4 is for lines. I'm going to go pick number 5. Quad. Right there, quadratic, okay? Don't get it confused with quart. No, I want quad. So number 5. And then I just enter. And then it tells you the numbers to plug in. So look, the 1 is going to go here. 1x squared minus 4x minus 5. It's giving you all the numbers you need. So let me write it here. So it'll be 1x squared minus 4x minus 5. And you don't even have to put the 1 in the front. So x squared minus 4x minus 5. That is the equation of that. Okay. So I went to Stat. You entered your points. And then, of course, you're going to choose number 5. Okay, so Stat number 5. All right. I want you to challenge yourself. Let's see who can come up with the equations here by using your calculator. Okay. Let's go to the next one. Number 4. Now they don't give us the graph, so we'll have to make a little graph after. What they do give us is the equation already. Now this is in standard form. Okay, that you learned from your notes from yesterday. Ax squared minus bx plus c. Okay, so here's what you do to fill in some information even though you don't have the graph. Okay, when something is given to you in standard form, the first thing I answer is the y-intercept. Because the last number, which is called the c, is always your y-intercept. So I'm going to put right here, 0, 14. That is my y-intercept. And notice, if I would have had the graph, I wouldn't have been able to see it because it only goes up to 5. And that doesn't mean there isn't a y-intercept. It just means it's all the way up here at the 14. So that's why it's good to know that shortcut, that if it's in standard form, the c is always your y-intercept. Domain, hey, that one you can still answer because it's always going to be all real numbers for quadratics. Okay. Now, it's important to look at the first number. Remember the first number is called the a. If a is positive, which it is, it's a 2, then it's going to open upward. Okay? Which means that if it opens upward, it looks like this. So whatever our vertex ends up being, it's actually going to be a minimum. So I'm trying to show you everything you can answer without even looking at the graph. Now, the next thing that you should be able to answer is, well, just knowing that it opens upward, you're not going to know the complete range or the minimum value, but at least you know that it's always going to look like this. Y equals, and all you need to do to get that number is to get the Y value of your vertex. Same thing here. Y, but not equals, range, if it opens upward, that means that those Y's are getting greater and greater and greater. So it'll be like that. And it's also going to be the Y value of your vertex. So maybe we should go find the vertex because that'll help us answer everything else without even looking at the graph. So how do we find the vertex? In your notes from yesterday, I gave you the formula for how to find the axis of symmetry. The axis of symmetry was x equals negative b over 2a. So let's do that. That's a, this is b. So negative b means the opposite of b. Well, b is already negative, so this negative with this negative makes it positive. 2 times a means 2 times 2. So now I have 12 over 4, which equals 3. So my axis of symmetry is going to be x equals 3. Remember, the axis of symmetry is not just the number 3. It's an equation of that vertical line. So you have to write it like this. X equals 3. If you only put 3, 3 is a point. 3 is just a dot. I need x equals 3 because that's going to be the vertical line that cuts it in half. If you know this, then that means you know this. You know that part. So now all I got to do is plug it in here so that I can get the y. Okay, I can do that, or I can use my calculator, and I can go to y equals, and I can type all of this in. 2x, and make sure you use a little squared here next to the comma, right here. 2x squared minus 12x plus 14. Oops, 14. And I'm going to go to the table. Second graph. When x is 3, what's the y? It's negative 4. There it is. So instead of doing it by hand, which by hand would have looked like this, 2, and you know x is 3, so you're going to plug in a 3 everywhere you see an x. 3 squared minus 12 times 3 plus 14. I could do it by hand. Let's see if I get a negative 4. 3 times 3 is 9. So 2 times 9. Negative 12 times 3 is negative 36, and then plus 14. This is 18. 18 minus 36 plus 14. This is negative 18 plus 14, negative 4. So yep, I do get the same thing by hand. But hey, you got the calculator, use it, right? So now that I know my vertex, I know everything else. Okay, I know everything else. I know that I can take this y value and put it here and put it here. Now you might be thinking, I don't know everything, miss. I don't know my zeros. Remember, zeros are the same thing as X-intercepts? Well, I could do this. I could take my calculator and press graph. Look. They're like right in the middle. Okay, so it'll be 1.50 and 4.50. There are your zeros. So you can just press graph and look to see where it's crossing the x-axis. Okay, so I'm going to put right here 1.50 and 4.50. So now you just make a sketch. You graph your vertex, 3, -4, and graph your zeros, 1.50 and 4.50. And you don't even need to graph anymore. It's just a sketch. There we go. And that's how you answer all the information when the quadratic is the one that's given. Okay? Now, another important thing to point out that as soon as I was able to put it in y equals and go to the graph, I would have been able to know that 3, -4 was my vertex. Because remember from your notes from yesterday, your vertex on the table separates the repeating numbers. You see that? So then that's your hint. Oh, that's the vertex. So you can also get the vertex from your table instead of going this route. But I like this route. All right. So make sure that you solve these. Yes, I solved them with you. Make sure you write everything down so that you understand what we're doing. Okay, and then now you just have, let's see, 2, 3, about 4 questions to do on your own. Take a picture of your work and upload it to your Google Classroom. And that's it for today. It is for a grade, so I will see you on Monday when we continue with characteristics of quadratics. Bye, guys.